In this video, I'm going to introduce you to library packages. It is a distinctly different library than the integrated library that we've talked about so far. And I'm going to show you how we can take an existing integrated library, that's that closed database, and crack it open to expose the symbols and the footprints. We're going to look first at using a library package as a global library. In a later video, we'll talk about how we can use local library packages. And once we open up that integrated library and we turn it into a library package, we'll be able to view the symbols and footprints in the library package. And I'll show you how we link a footprint to a symbol by the database name. So remember to keep straight. Integrated libraries, closed global databases, library package, a different kind of structure. Let's take a look at that in the Altium Designer tool. So far, we've been looking at integrated libraries. These are closed databases that are global. One integrated library is going to apply across multiple printed circuit board projects. And we saw before that we can find the integrated libraries going to the Components panel and then pull down the ones that are installed. Now I've already uninstalled the default integrated libraries that come with Altium, and all we have here are the two integrated libraries that we've released for the class. And remember, the extensions are really important. Int library, that's the integrated library for these two releases. And when we open up the integrated library in the components panel, we see all of the components that are in there. At some point you may think that, okay, I have too many components in this library. If I have 10,000 components in my integrated library, maybe it's time to think about reorganizing the integrated libraries and creating multiple integrated libraries. And that's certainly something that you can do or your librarian can do. But for all the parts in our class, we're not going to be talking about more than a couple hundred, and that's easily manageable in one integrated library. The good news about the integrated library is they're curated, and in this case there's a good linkage between the symbol and the footprint. The bad news is if I want to change something in the database about a component, I can't do it. It's a closed database. I can change information about an individual component once I've added it to the schematic. So for example, if I have a white LED, I double click, it's now available to put on the schematic page. I've placed it there. When I double click on it and open up its properties page, we see, yep, here's the design item ID, here's the integrated library it's from and it's available to us, here's the footprint. If I wanted to change the information about that LED and say, you know, its value right now is what's being displayed as its color. If we come over here under parameters and we see value and white, of course if we turn that value off, then and we push OK, then it's gone. But I like having that information there. But you know, maybe I wanted to change this and it's not just white, it is power on. I want to change that. I'm only changing the information about that component, that specific element in the schematic. I'm not changing the database. So if I say, yep, that's what I want, I say, okay, I've now changed the label for that part. But now when I go and I place this part again on the schematic, of course, it's back to this is what is in the database. I'm not changing the database. That's the downside of an integrated library. I'm going to show you now how we can take that integrated library and we can create a library package. Really important to distinguish. Integrated libraries, closed global databases. Library packages, open databases. When we first create it from the integrated library, we're going to open up that integrated library and get access to each of those components in our library package. We'll create it as a global, and then in a later video I'm going to show you how we can tie that to a specific printed circuit board project so it lives in that project and can only be used in that project. So to illustrate how we can take an integrated library, which is a closed database, and open it up so we have access to those parts and turn it into an open database in which we can change the entries for each of the database elements, I'm going to first close the 08 integrated library so that we don't have it installed. So we're going to come over here to the editor. We're going to take the '08 library and we're going to remove it. And so now it's not available to us. We only have the one integrated library. And now I'm going to go ahead and open up that integrated library using one of the tricks that I showed you earlier. We find the folder in which we have our integrated libraries. So here's my folder that have all of my circuit board design projects. I have this one folder labeled libraries at the top. Open that up, and here are all the files associated with my libraries, and here are those two released integrated libraries. Let's take the '08. We're going to double click, and now it comes up with our option menu. Do we want to install the library? That's our normal path, or extract the sources. And that's what we're going to do in this case. We're going to extract the sources, and look, it's thinking really hard, it's working, and now it's done. And what we have done is taken that closed integrated library database and opened it up and turned it into a library package. And you can see here in the hierarchy of the projects window, one project here is the Practice 1 project. That's the circuit board we built. And look, there's another object in the database here that's at the same level of a project, which is the library package. A library package is an open database that is considered by Altium to be just like a project. And when we open it up, we see that there are two other objects in the library package, each of them with a library extension. This one has a PCB lib extension, this one has an SCH lib extension. These are the kind of the two parts, the two chapters of the book that is going to be turned into the components. And when we open up the library package, which is the open database, we're going to have access to each of the components, the chapter 1s, which are going to be the symbols, and their chapter 2s, which are going to be the footprints. Now, wouldn't it make a lot of sense if instead of labeling the library as SCH lib, like kind of schematic lib, and PCB lib, since the information in this database is all about symbols, why wasn't it called SYM library, and this one FT library for footprints? Well, legacy code. And so we just have to remember that when we have an SCH lib, those are symbols that are going to go onto the schematic. And when we have a PCB lib, those are footprints that are going to go onto the layout of the PCB. Now we can look at these two databases. Let's look at the schematic one first. These are going to be the symbols. So I double click to open it up, and you'll notice down here in the projects, hey, we've gotten a new tab. This is the SCH library. This is the when you see SCH, think schematic, and when you think schematic, think symbol. This is the symbol library. Let me click on it, and here are all of those design item ID elements. This is going to be the name of the book, the name of the component, and when we click on one of these over on the right hand panel, that's where we see the symbol. So this is where we can identify the symbol, and we can edit the symbol as well. And we'll talk about editing symbols and also bringing symbols in from outside in a later video in this series. But for now, you can see all of those components labeled by their design item ID available to us here as their symbol. And it's in this open database that we'll be able to edit any of the components in the database. And that, of course, will apply to everybody. Let's take a look at the other component here. This is the PCB lib. And remember, when you think PCB, think that's going to go on the layout. And what goes on the layout are the footprints. So this is going to be the footprints. So if we double click, we get a new tab at the bottom that says PCB library. We'll open that up. These are all the footprints that we have available associated with those symbols. And of course, the footprint and the symbol go together for each book or each component. Now, there are some of the footprints are used multiple times, and notice their names. And so each footprint has a very specific name. This is how it's referred. This is how it is linked in the database. So in order to check the linkage, in other words, for example, we have here's the 328, the microcontroller. Here is the footprint for the 328. we want to make sure that that footprint is linked to the symbol for this component. And the combination of the chapter on the symbol and the chapter on the footprint get bound together into one book that will go into the integrated library. But right now, this should be linked to the symbol. Let's check that in the symbol library, which is the SCH lib. So we go back to projects, we go open up the symbol, we check in here, and let's see what's that going to be. That's a microcontroller, so it's either a U or a Q. Q is usually for a transistor, U is for an integrated circuit. So we look down here, and sure enough, here it is. It's a U at Mega 328. So let's double click, or click once. Here's the symbol for it. Yep, that's what we're expecting to see. We got a lot of IOs here, we got a lot of other pins, and sure enough, look, in the bottom part of the screen, we have the footprint information. It knows this part has this footprint linked to it, and it's linked based on the name, because this is exactly the same name as used in the footprint library. When we have a symbol in the same library package as the footprint, as long as we have the footprint name in the bottom part of the screen here, that footprint is now linked to that symbol part. And later we'll see how we can change that around if we want to, or we can go in and edit that footprint. So if we were to go back to the footprint library and edit this part and not change its name, that re-changed, edited footprint is going to still be associated with this specific part. And the combination of the two of them make up one component, and that's what goes in the integrated library. So what we've got in the library package is the open database that allows us to manipulate the symbol information and the footprint information for that part. In addition to the symbol that we can change and edit over here, we also have available to us the properties. This is where we can go in and change any of the database entries. So if we wanted to change the URL, so here's the URL to the link on the DigiKey page. If we wanted to change that link, then we'd come over here and change it. That would change the database entry for that component. We have the value here. If we wanted to change it, again, we would make the change in this entry, and that would change the database entry for this component. This is why we call it an open database, because now we have complete access to all of the components in our library and can change all those components. It's also important to note, down at the bottom, this is how we access all those components. And so it dynamically changes based on what we've selected. So we have the library here, we got the PCB library, we got the database, the symbol over here, we got the symbol library over here, and we can select any one of these guys. So that is the library package. Very, very different from the behavior of an integrated library. And I'm going to show you in a later video how we can manipulate the symbol and the footprint for either an existing component or add a new component. And it's important to note also that this is global. This library package is going to apply across all our circuit board projects.